Hello, I'm George. I'm going to be talking about linear programming, graph method of it. So, linear programming, linear programming is a method of finding the optimal solution to a problem mathematically. A simple example would be either maximizing profits or minimizing costs. So, the history of it. Method for solving a system of linear inequalities was published in 1827 by Joseph Fourier and Theodore Motzkin. However, the first linear programming formulation of a problem that is equivalent to the general linear programming problem was given by Leonid Kantorovich in 1939, who also proposed a method for solving it. He developed it during World War II as a way to reduce costs to the army and increase losses to the enemy. In 1941, Frank Loren Hitchcock also formulated transportation problems as linear programs and gave a solution very similar to the later simplex method. Okay, so first thing you want to do with linear programming is define your decision variables. So that'd be what makes up the axis. So decide what your x and y variables are. After that, you want to define the objective function, so what you are trying to maximize or minimize. Then after that you find constraints, which will be inequalities that using the variables that will help to find an optimal solution. Then you want to plot a graph using the decision variables of the axis, and you plot the inequalities and then shade any areas that the inequalities will make a feasible region, as shown on there. And you want to shade out the areas not on it, so you've clearly got a feasible region. Then after that, you want to be looking for an optimal solution. And you can use simultaneous equations to calculate the x and y of each of the vertices of the feasible region. So for simple problems, if you're maximizing, you look for points. You look for the point furthest away from the origin, and if you're minimizing, you look for the point closest to the origin. Calculate the value of the objective function using the optimal x and y point that you find furthest away, or well, in this case, furthest away, and that will be the solution. More complex problems wouldn't use this method. They'd use another method. So here's an example. You're in charge of buying new cupboards for a school classroom. The cupboards are available in two different sizes, standard and large. The maximum budget available is £1,800. Standard cupboards are £150 and large cupboards are £300. So it's maximization problem, and it would have that objective function, 150 x plus 300y is less than root, so 1800. So that would be, so the decision variables are the small and large cupboards, that's your x and y, and that's your objective function. So inequalities, the cupboards will be fitted along a wall 9 meters long. Standard cupboards are 0.9 meters and large cupboards are 1.2 meters. So that also must be two large cupboards, and that would give two constraints there. So after that, you plot that on a graph, which gives you that, and the R is the feasible region, marked off by two lines at the top. Those two lines on that one at the bottom. That's the feasible region. The dotted line will be the objective function line, which you can use to find the point furthest away from the origin. So the optimal solution here ends up being 6 standard cupboards and 3 large cupboards. So that's this small intro to the linear programming, the graph method. Thank you.